I thought it'd be a good time to just go back and review some things. So critical points, inflection points, we'll do this just really quickly. Okay, this should be easy. So for critical points, that's where the derivative is 0 or undefined. So f prime of x is 6x squared minus 6x minus 12, which I could pull a 6 out, x squared minus x minus 2, which I could factor to be x minus 2 and x plus 1. So if we're looking for where the derivative is 0 or undefined, the critical points, I'm going to put my answers over here, critical points would be x equals 2 and negative 1. Okay. Now inflection points, well, now we're going to need the second derivative, which would be 12x minus 6. Now inflection points are where the second derivative changes signs. Now this is just a linear function. It would cross the axis at 1/2, and that's important. Okay, and I'll come back to that in a second. But inflection points, the inflection point occurs at x equals 0.5. All right, increasing, decreasing. Let me do a little sign analysis here on my derivative. I'll plug in negative 1 and positive 2. And if I plug in a number less than negative 1, I'd have negative multiplied by negative, and that would be positive. If I plug in a number between negative 1 and 2, I would have negative and positive. That would be negative. If I plug in a number bigger than 2, I would have positive, and that is positive. Okay, so now I can answer some questions here for increasing, or increasing when the derivative is positive, so from negative infinity to negative 1, and from 2 to infinity. We are decreasing when the derivative is negative, so between negative 1 and positive 2. All right, the next question, concave up or down. So now I need to do a little sign analysis on my second derivative, 0.5. If I plug in a number less than 0.5, I'll get a negative. If I plug in a number bigger than 0.5, I'll get a positive. Okay, so we're concave up when the second derivative is positive, so from 0.5 to infinity. We're concave down when the second derivative is negative, so from negative infinity to negative 0.5. So I've answered everything. I just want to go back and again remind you that an inflection point occurs when the second derivative changes signs. So, you know, I knew that it was a linear function. I knew it actually did change signs up here, but we actually do have to see a sign change in order to verify that it is an inflection point.